Once more into the breach, they say. Beam me up, Scotty. We're back to quantum teleportation.
Yeah.
Now, there's some very interesting stuff going on here, but let's talk about what actually happened here and what they're testing when they're talking about quantum teleportation. What's happening here, John?
Yeah, so before you guys start getting into the comments saying, oh, you've already covered this. But we did it was so let's just dive into this quickly. So we're talking about quantum entanglement, okay? And for those of you that don't know, it's where two particles become so deeply linked that the state of one instantly influences the other, no matter how far apart they are. So traditionally in these kinds of experiments, we'll call it quantum teleportation. It required isolated, specialized fiber lines to protect the quantum signals from being drowned out by the millions of photons used in classical internet traffic. Now, the innovation here, which is awesome, which is super cool, is that researchers at Northwestern University have demonstrated that quantum teleportation can occur over busy, real-world internet cables by carefully selecting less crowded wavelengths and using advanced filters to minimize interference. So how they did this was they set up a 30-kilometer, or for those of you in the US, 19-mile fiber optic cable with a photon at each end. And they sent both quantum information and regular high-speed internet traffic through it simultaneously. And at the midpoint, they did a quantum measurement, I don't know what they did, enabling the quantum state to be teleported from one end to the other without the photon itself traveling the entire distance. So the cool thing is that the quantum information arrived intact, even with heavy classical internet traffic present, which proved that quantum and classical signals can coexist in the same infrastructure. I'm not surprised, but are you surprised by this? Because I'm not, based on what we've covered.
I'm surprised they found it already. I guess I'm not.
What's right?
I'm surprised they found a way to do this already.
Okay.
Optical stuff, when you're talking about isolation traffic over there are always leaps. We can always send more beams of light. In 10 years, we're going to say now we can send 100 beams of light down this thing when we used to be able to send 10. So this changes a lot. I remember back in the day when we were building data centers and we were switching from copper to fiber optics and the different node. So it always changes. But
yeah,
again, what I'm surprised is that they've come about this so early in the quantum network process. It says, hey, we can now send these signals over something that's already carrying 400 gigabits plus per second down that's heavy, and it still works. Versus, normally everything we've been dealing with quantum, it needs to be isolated. Any sort of temperature fluctuations or electrical fluctuations or whatever will disrupt anything in the process. It has to be a certain temperature. It has to be all these things. So when we see something like this, where it's saying, hey, this can actually operate in existing networks today, we don't need to necessarily build a whole new quantum network for quantum computers to communicate in this quantum stuff. I'm shocked that we found out this early. That's all I'm saying. I was figuring we could do it. It's just that we actually don't have much in the way of quantum networks built yet. I'm surprised we found out so fast. That's all.
Yeah, we don't even have a quantum computer, but we have a lead to transmit quantum communication, right?
Yeah.
Or quantum information.
So
what I'm curious is 30 kilometers. Why? Like, did they pick that? I'm curious to know why they picked that length. Obviously, they're going to test longer length, but I'm curious as to why 30 kilometers and not 50 kilometers or 100 kilometers or 10 kilometers. So this is cool.
So do you want an answer to your question, or you just okay? So benchmark for quantum coherence, 30 kilometers is long enough to be challenging due to signal degradation, photon loss, and decoherence, but still within reach using current quantum technologies and error correction. Test of real-world viability is meaningful distance to simulate real-world deployment, such as communication between buildings, campuses, or city centers. But from a telecom compatibility, standard fiber optic segment, 30 kilometers is common span in metro scale telecommunications infrastructure, making it a realistic test for integration into existing networks. And signal attenuation sweet spot. It represents a critical threshold where classical fiber still performs well, but quantum signals begin to degrade noticeably, providing a valuable data for future repeater development.
There we go. Thanks for the answer.
Okay. This choice of 30 kilometers builds on previous successful experiments at 10 kilometers and 20 kilometers, pushing the boundaries while staying within a manageable risk of proof of concept. Go on.
So this is great, interesting, excited. I love that we have a way to send information without having a computer to actually use, but this is cool.
Tired of drowning in repetitive tasks while your competitors race ahead? Every minute you spend on manual data entry, scheduling, and routine processes is a minute you're not growing your business. Flowgrammer.ca transforms your workflow chaos into seamless automation. We build AI-powered systems that handle your busy work so you can focus on what actually makes you money. Our clients typically save 15 plus hours per week and see their productivity double within 60 days. Visit flowgrammer.ca for a free automation audit. That's flowgrammer.ca. Stop working in your business and start working on it.
So what do you got going on, John?
Yeah,
July now.
I'm working on a webinar in August or September on shred and IP development or IP strategies. So watch out for that. Otherwise, I'm going to enjoy July. I know a lot of people are taking July off, but yeah. How about you, Craig?
Well, we won't be having a Startup Investor Drinks in July, but we should be having a Flowgrammer event and probably off the month of August. But if the group of Flowgrammer people want to have an August event, we'll do that as well. Other than that, I'm heads down. I'm working with clients now, building AI automations, and it's been fun and great. And right now, I know you're heads down working with clients on getting them funding.
Lots of programs. Well, not as many as before COVID, but still lots of programs. Exciting to see what opens up this year with the new liberal government in power. And yeah, so we'll have to reach out to me on LinkedIn if you have any funding needs. But if you overall need some business help, how about where they find you, Craig?
Check out torontostarts.com for everything we do. It's all there. But we have a couple of branch websites, startupcoach.ca, where you can book some time with me. You can go to startupdrinks.to to find out our Startup Investor Drinks events, or flowgrammer.ca to find out all the information about business automation and how you can take your business to the next level utilizing AI and automation tools. And until next time,